Okay, let's review dependent and independent variables. A dependent variable is a number or a variable that is affected by another variable. So if I say, in this case, there are 2 reds for every 2 blues, I can put any number of blues in there. That would be the independent. But if I put 4 blues, there automatically have to be 4 reds because the reds are dependent on the blues. In an independent variable, one outcome is not affected by another outcome. So if you see in this example of the heads and tails, I can flip it and it could be heads, or I can flip it, could be tails. One is not dependent on the other one. So we're going to look some more today at these sequences. And I want you to look right here, or patterns. And look right here at these triangles and see if you can come up with the pattern for what is happening there. Okay, so I'm going to make a table right here to organize my information. And I know I have one variable is t, that will stand for the triangle. So first triangle, second triangle, third triangle, fourth triangle. That's what this t is for. The c is going to stand for circles in the triangle. So these are my 2 variables. T for triangles that are formed, and c for the number of circles. So in the first triangle, there is 1 circle. In the second triangle, it takes 3 circles. In the third triangle, it takes 6 circles. And in the fourth triangle, it takes 10. See if you can figure out how many circles would be in the fifth and sixth triangle. Now, the triangles are the independent variable here because I can put any number of triangles. But if I have 4 triangles, there must be 10 circles. So the circles are the dependent variable. See if you can figure out the pattern that's going on here, and then see how many circles will be needed for the fifth and sixth triangles. You should be able to see that between 1 and 3, so you're usually looking at, okay, first of all, what is the operation? Is it adding? Is it subtracting, multiplying, dividing? Well, if I first try out this, obviously it's going up, so it has to be adding or multiplying. Those are the only 2 operations that will cause it to go up. So I can try adding first. This would be plus 2. If I say plus 2, okay? Or I could also say times 3. So I'm going to keep that in mind right now. It could be plus 2. I'm just going to put it right here, plus 2. Or it could be times 3. This will help me kind of figure it out when I go to the next one. Now let's try out this here. Well, if I'm either adding or multiplying, again, it's going up. It's not plus 2. It would be plus 3. Or I could say times 2. So I'm kind of seeing a pattern here. It's plus 2 here, plus 3 here. That went up 1. And then if that were to continue, right here would be plus 4. So let's check that out. 6 plus 4 is 10. So that looks like that pattern is following. If I look at the other pattern, the multiplication pattern that I was starting to notice, I said times 3 times 2. This one would have to say times 1. 6 times 1 does not equal 10. So it's obviously not a multiplication pattern. It's got to be this addition pattern. This makes sense. Plus 2, plus 3, plus 4. So right here would have to be plus 5. So 10 plus 5 would make 15. And then right here would have to be plus 6, meaning this would have to be 21. If you look at this one, James has $20. He spends $2.20 every day on his school lunch. Write a sequence or a pattern to show how James will spend his $20. How much money will James have left after 3 days? Well, okay, D is for days, right here, there's my first variable. M is for money, that kind of got messed up. M is for money. And so on the first day, he spends $2.20. And so I already did the calculation.
What?
So if you say $20 minus $2.20, that will give you $17.80 on the first day. Then on the second day, you have to subtract $2.20 from what he has left. So that would be $17.80 minus $2.20. That will give me $15.60. On the third day, you have to subtract $2.20 from $15.60, and that would leave me with $13.40 after 3 days. So in this case, they've given us the pattern. They've given us the pattern. It is subtract $2.20. That's the pattern. Sometimes they don't give you the pattern. They just give you both variables, and you have to figure out the pattern. So in your assignment today, you are going to do pages 313 and 314. It's kind of split between those pages. And you're going to do problem number 1. And then you're going to skip and do 3 through 6. So 3, 4, 5, and 6. And then skip again to number 15. Now for as many as you can, I want you to make a table to organize your information so you can see the two variables. One will be the independent variable. That's usually the one on the top. Or we could call it the X variable. You can use any letter for your variable. You can use one that makes sense. So if you're talking about tables, you could use T. And then you're going to figure out the pattern and fill it in. And in some cases, they may give you the pattern and you just have to fill in the table. Or in other cases, they may give you the information in the table and you have to discover the pattern and figure out the next few. So write down these problems right now so that you know, because when this video goes off, then it won't be up here anymore.